Hello all. Through this presentation, I'm going to discuss the practicum project that I worked on. The project that I worked on is titled Performance Trend Classification, and I used CNN Convolutional Neural Network to build this project. The first slide that I have here is problem statement. For the success of any data science project, it's very essential to understand the problem that we are trying to solve through machine learning. So the problem that I choose for my practicum project is actually something I faced in my work environment, and I wanted to take this opportunity to build a model or use data science that can help me resolve that issue. So a little background. I work in the telecom industry, and one of the tasks that I do is look at the wireless network mobile sites, and there could be thousands of sites. And sometimes we have to investigate if there is any degradation or if there's any improvement in the performance. So the existing methodology that we have is to use Excel to perform a pre and post delta analysis. Basically, you take some pre KPIs and then you consider some post KPIs and you try to calculate an average base delta to decide if there is any degradation or if there was an improvement in the performance. The challenge that we have seen is when we do average based delta analysis, we see sometimes a lot of unwanted noise that we have to tackle, and sometimes that wastes time. An example you can see from the image here. The image here shows 30 days of performance. You can see the performance has been quite consistent, and there was some issue which caused the performance to degrade for 2 days. You can see highlighted by the dotted circle here. And if I have to do a pre-post delta analysis average base, the 2 days fluctuation will mislead the results and it will show that there was some degradation in the post KPIs. Although the issue was intermittent, it caused some degradation for 2 days, but then eventually the KPIs return to normal. So if I'm trying to find degraded sites from thousands of nodes, I don't want this to be in my analysis list, because it was something intermittent and it actually improved. So to avoid this kind of problem, I want to propose a solution which uses data science, and I want to build, I want to do an image classification instead of Excel based delta analysis. And I want to use CNN to learn and to be able to classify an image into whether it is an improved performance or neutral performance or degraded performance. So that is the project I decided to work on. So the project, my performance trend classification using CNN, I'll divide it into 5 steps. One is problem understanding, something we discussed. Second is understanding the data that we'll be using. Third is preparation of the data that will be used as an input to feed into the CNN model. The fourth is the modeling, where we'll be building the CNN models to classify the images. And the last is the evaluation of the models that we have built. Let's understand the data that we'll be working on. For this project, I collected 30 days of performance data, and I've essentially collected call drops KPIs, which includes the call drop percentage and the raw number of call drops. I will be dividing my project into 2 parts. For my part 1, I'll be using only one feature, which is call drop percent, and for part 2, I'll be using both the features. The raw data has 4 columns. First is the date, second is the anonymized name of the sites, third is the call drop percentage, and fourth is call drops. And the performance data was collected for more than 2,500 sites. Let's look at the data preparation. The raw data that was collected was in tabular form, and it had 30 days of performance data for each wireless node. Once I had that data collected, I converted the tabular data into a line chart, and so I have more than 2,500 line charts, one for each node. You can see a sample image here. What it shows is 30 days of performance data. So I have more than 2,500 images like these. Once I had that, I did a manual classification into three categories: improved, degraded, and neutral. And further, the images were distributed into three data sets: train, validation, and test. The model will be trained on the train data set. It will validate with the validation data set, and then will test the accuracy of the model on the test data set. So some more details on the data. So overall, we had 2,547 images, which were divided into, which were actually manually classified into degraded category, improved category, neutral category. For the neutral category, I had like more than 1,600 images. Improved images were around 384, and the degraded images were 410, which were further subdivided into training data, validation data, and test data. You can see the number of images for each category into the training data, validation data, and test data. Let's look at the modeling. So, like I said in the beginning, I use convolutional neural network to build the classification model, and the CNN model was trained on the training data, and validation was done using the validation data. We divided our data into three sub-data sets, which was training data, test data, and validation data. Model was tested on the test data, and accuracy was recorded. The fine-tuning of model was done to improve the accuracy. We'll see in the further slides what kind of model tuning was done. And I also used transfer learning and functional APIs to achieve further improvement in accuracy. On the bottom here, it's a basic architecture of our CNN. So we have an input, we have convolutional layer, we have activation function, we have pooling layer, and then we have fully connected layer. Let's take a look at the evaluation. Once the model was built, I checked the testing accuracy and the validation accuracy. The accuracy metrics that I used was classification accuracy, which tells the correctly predicted images out of the total number of images. For my project part 1, I used 4 models. The first model that I built was sequential API using Keras. I was able to get an accuracy of 67%. The second model that I built, it was using functional API, but I didn't see much improvement in accuracy, and still the accuracy was around 67%. The third model I built was using transfer learning, and I used Inception V3 model, and I was able to get an accuracy of 82%. And the last model that I built, it was again transfer learning, but this time I used VGG16, and it gave an accuracy of 86.6%. So out of all the 4 models, VGG16 gave the best accuracy. And I used the same model in the part 2 of the project, where I was trying to classify the images, which has 2 features. The accuracy that I received was 73.9%, which is less than the accuracy that I saw for the images with 1 feature. Let's take a quick look at the different models that I built. So the first model here is, like I said, the sequential model. So the sequential model I built had 4 convolutional layers along with the ReLU activation function. There were 4 pooling layers and a fully connected layer. I used the dropout layer to prevent any overfitting. So the dropout layer is a mask that nullifies the contribution of some neurons towards the next layer and leaves unmodified on all others. So you can see the model summary on the right. It shows you the convolutional layer, the pooling function that I use, and the dropout. The testing accuracy was 67% as shown in the snip below. Let's take a quick look at Model 2. The Model 2 was built using functional API. The functional API in Keras is an alternate way of creating models that offers a lot more flexibility, including creating more complex models. You can see the model summary on the right. And with functional API, I was able to get accuracy of 67%, which is pretty much the same that I got with the sequential API. The Model 3 was built using transfer learning Inception V3 model. The Inception V3 model is a convolutional neural network that was introduced by Google, and it achieved the top results in ImageNet large-scale visual recognition challenge from 2014. So I utilized this available model, and I was able to achieve an accuracy of 82%, which is better than the previous 2 models. For the last model, I used transfer learning, but this time I used VGG16. which is a convolutional neural network trained on 1.2 million images to classify 1,000 different categories. With VGG16, I was able to get the best accuracy of 86.5%, which is higher than the accuracy seen with the previous three models. For reference, the VGG16 architecture is shown at the bottom of the slide. So far, I talked about the first part of the project. Now let's take a look at the second part of the project, where the images that are generated has two line charts which represents two features, call drop percent and call drops. Sample image is shown on the right. Once I had these images generated, I classified them into degraded improvement and neutral category, and then further subdivided it into train validation and test data so that the model can get trained on the train data and can validate using validation data and can test and can be tested on the test data. I used the VGG16 model because it gave me the best accuracy in the part one of the project, but when I applied this VGG16 model in the second part of the project, I could only get an accuracy of 73%, which is less than what I saw in the first part of the project. Finally, concluding my presentation. So I built multiple models to classify the images into three categories, which are improved, degraded, and neutral. The transfer learning VGG16 was able to give the best accuracy of 86.5% when it was used to classify the images with one feature. When the same model was used to classify the images with two features, the accuracy of 73% was seen, which is less than the part one of the project. One thing to keep in mind is most of my time was spent in the manual classification of images for preparing train, validation, and test data. And it's quite possible some of the human errors were made while manually classifying these images. So further efforts have to be put in to improve the accuracy for classifying images with two features. And once I have some success in getting more accuracy or better accuracy for the part two of the project, I will consider consider the deployment of this project into my workplace so that I can replace the existing methodology with an improved methodology which uses machine learning. And this is the end of my presentation. Thank you.